Hello and welcome to week 4. I wanted to take a few minutes and kind of go over a few examples of this week's lab that people tend to struggle with. It's not an overly difficult lab, but people do get a little confused on a couple of the issues. So I am going to share my screen and we are going to hope this works. Okay, the first half of the lab is on calculating relative humidity, and when given the air temperature and dew point, that one is fairly straightforward. But later on in the assignment, I have you find either dew point or air temperature, and this is where people start to struggle. Please show all your work or you won't receive any credit. And please do not use an online relative humidity calculator. You won't quite get the same answer as you do by using the table that I've given you. So down here, it says if the air temperature is 85 degrees Fahrenheit and the relative humidity is 13.37, what is the dew point? So I set it up the same way as before, but instead of solving for humidity, I already have it. So I'm going to change my percentage to a decimal. That makes it 0.1337. I think I did a point. I'm going to set that equal to X because I'm looking for my amount of humidity. And then I'm going to divide that by the capacity of 85 degrees Fahrenheit, which is 26.48 grams per kilogram. So now if I cross multiply and divide, I would get X equaling 3.54. And if I go back to the table provided, 3.54 is about 30 degrees. The one below is very similar, except instead of finding the dew point temperature, we need to find the air temperature. So again, I will start by changing my percentage humidity to a decimal, and I set that equal to 55-degree air can hold 9.32 grams per kilogram of water vapor, and I will divide that by X. Now, when I cross multiply and divide, I get 0.492 X equaling 9.32. And then I have to divide both sides by 9.32, and this gives me 18.94. And if I go back to the table, 18.94 is 75 degrees. And I hope this helps out a little bit. You basically work it the same way, you're just solving for a different variable. The next one that people really seem to struggle with is the lapse rate table. The first question on that part just looks at the environmental lapse rate. It's not too terribly difficult, but people tend to struggle with the table. It looks like this. So I have imagine a parcel of air that has 26 degrees Celsius and a dew point temperature of 6 degrees Celsius. Assume that the environmental lapse rate is 7 degrees per 1,000 meters, and the environmental lapse rate can vary. 6.5 is a ballpark average, but it really depends on the specific area. The dry adiabatic lapse rate is 10 degrees Celsius, and the moist adiabatic lapse rate is 6 degrees Celsius. All right, so we're going to start here in this middle one with the environmental temperature. That's where we just go with the environmental lapse rate. So it's going to decrease by 7 as we go up in the atmosphere. So if we go up 1,000 meters, that's 7 degrees less. And if we go up another 1,000, we take off another 7, and so on and so forth. Okay. Now, the part people struggle with is the parcel temp. And for those of you who are in the flight program, I realize that yes, the dew point does decrease a little bit as you go up in elevation, but I am trying to keep the math as simple as I can for this particular question, just to give people an idea on how an environmental temperature and a air parcel temperature can vary. So as long as the air is dry, meaning warmer than the dew point, we will subtract off 10. So we go up 1,000 meters at 16, we go up 2,000 meters at 6. Now we are at the dew point. This would be where your cloud base would start to form. So now instead of decreasing by 10, we will decrease by 6. So we'd be at 0, we'd be at -6, -12, and so on and so forth. And as far as determining stability, you can read the rules for air parcels and read in your chapter 4 in your textbook, and it will kind of go over stable, unstable, conditionally unstable, and all those good things. The same is kind of true for that last question on the back, except, let me see, I can't roll down. So now my base is at 22 degrees Celsius. The dew point is 2 degrees. The dry rate is 10. The moist adiabatic rate is 6. We're not going to worry about the environmental rate. We are only concerned with the air parcel in this question. So again, as long as it's above the dew point, you're going to decrease at 10 degrees. So we would go from 22 to 12. And then at 2,000, it would be 2. Now we are at the dew point. So this is where you get clouds. My cursor doesn't write very well on here. And then as we go up to 3,000, you would decrease by 6 instead of decreasing by 10. Now, as the air gets to the top of the mountain, assume that it has released all of its moisture and it's dry, so you will warm up by 10 degrees going down the entire way, and so you'd be back to 30 at the base. And I hope this helps a little bit. As always, feel free to reach out to me. I will help you as much as I can. If you are an on-campus student, you can always stop by. Hope you have a great week. Keep up the good work.